Good morning, everyone. My name is Grace Farrow. I'm a Solid Edge Application Engineer for Prolim. And today we're going to be going over the Solid Edge 2021 Updates Part 1. So just to get started, we're going to kind of look over this agenda real quick. We are going to be looking at mechanical design updates, sheet metal assembly part modeling, and that has the highly anticipated subdivision modeling as well as drafting. And then we're also going to look at management updates, so Solid Edge data management. We're going to look at the shape search as open command pack and go enhancements. There are going to be a lot of hands-on demonstrations and some just explaining with slides. So let's go ahead and get started. The first thing we're going to look at is the sheet metal multi-edge flange tool. So now we have the opportunity to create multi-edge flanges in a single go. The same parameters are applied to all edges, so you can specifically click on just one edge if you just want one controlled. We do have miter support, so that miters flanges created in this multi-edge flange command. And then we also do have a trim, so that's a toggle for an automatic trim. And we're going to go ahead and take a look at this in a demonstration. So the first thing we're going to do is we're going to look at that new multi-edge flange tool on the Home tab while we're in a sheet metal part. We do have very similar options from other flange options, and there's that miter option we're going to take a look at in just a minute. We do have the option to select edge or chain. For this example, I did select edge, and what I'm going to do is I'm actually going to select all of the edges on the same side. If you select the other side, you will have flanges that go in the opposite direction. So I selected my edges, and I'm just going to pull up. This is a very synchronous looking operation while still in ordered. It kind of gives you that ease of use feel. And I'm going to enter in a distance, and then right click to say OK, and then I'm going to finish this up. We can see how easy and simple that multi-edge flange was. We're also going to create more now, selecting these edges that I've shown. I'm going to bring them together, and you're going to see that they're going to all touch each other. I don't have my automatic trim on. I'm just going to turn on trim. And what that's going to do is it's going to trim those edges so they don't touch anymore. I am going to add a gap of 5 millimeters just to show how easy that is and what that kind of looks like. And then I'm going to right click to solidify that and then hit finish. And we can see how easy that part was created in such a short amount of time. And now I'm going to go to my next example, and we're going to look at that miter option. So again, I'm going to select my edges that I want. And this time I'm going to, instead of changing the distance, I'm going to change the angle to 120. And we're going to see how those edges don't touch until I go back into my options and select that miter. And then pull that up, and we see it just automatically does that for us. And then I can left click to place my distance, and then I can finish. I am going to go back into my options, though I kind of want to just show more of these advanced options in here. So we do have a full width or centered. And then we also have the option of measurement inside or measurement outside, and then we have the material on the inside, material on the outside, or the bend outside. So just a little bit more into the tool and the options that it has. And now that we're done with that, we'll move on to the next thing. So the next sheet metal enhancement we're going to look at is the flat pattern relief path. So the relief path allows users to remove undesired reliefs from flat patterns. So this is created, the auto reliefs is created by lofted flange, are the most obvious targets for this command, but we also allow the user to patch, bend, and corner reliefs. Bend's lines will not be modified by the command. They will remain as they were in the drawing before the patch was placed. So let's go ahead and take a look at what this looks like in an example. So for this first example for relief path, to get there, it is for your flat pattern tools. So we do need to go into flat pattern, go to the tools tab, and there that is. We can select that relief there one by one. We can window, or we can hit A and select all of them, which is what I am doing. And we're going to see all of the little green dots pop up. And then when I say OK, we can kind of zoom in here and see those sketches that are being applied. So when I hit finish, you're going to see those relief paths have been added. Okay. So I'm going to go to my next example. And for this example, we're going to edit that sketch a little bit. So again, I'm going to go into that flat pattern. I'm going to go to my relief path tool. And again, we can either select one by one or hit A and select all of them, which is what I'm going to do. And then this time, I am going to edit that drawing profile. And all I'm going to do is just kind of create a different shape than this regular rectangular shape that's being provided. And we're going to see how that looks after we finish this command. So again, just creating that shape, going to trim this out, and then close out this sketch. And then when I hit finish and I zoom in, you're going to see the difference in those relief paths. You know, so that's one side and that's the other side, and I did edit that relief path manually. So this is a really great tool for sheet metal, really great tool just in general. So moving forward, we're going to look at assemblies. So for our assembly updates, the first thing we're going to look at is locate on inactive parts. So this is going to reduce the need to activate all of our parts in a large assembly, and then elements can be located on inactive parts. So this is going to improve assembly performance through lower memory usage. This is also going to improve usability by reduced need to activate parts to perform assembly actions. So we're going to go ahead and take a look at this in an example. So here I have an assembly, and if I want to turn the locate inactive parts on, I'm going to go to my options. Then I'm going to go to my assembly tab, and down here I can turn that on if I want to with that checkbox. Or under the select group, I do have the opportunity to turn that on from there, the toggle. And what I can do now is I can actually come into those inactive parts, select those, and now I have the opportunity to create measurements from those inactive parts. I have the opportunity to update some of the relationships. I have the opportunity to even move these. And what this is going to do is it's going to reduce that need to activate parts. So it's going to improve that assembly performance through lower memory usage. And just overall, it's a really great feature, especially if you use large assemblies often. Here's an example of me I'm just going to pull this out just so we can kind of see it a little better. I am not going to suppress any of those instances, so it is going to move back. But again, just all around a great tool. So the next assembly update we're going to look at is the new copy-paste functions. So this is going to allow users to copy, paste, and assemble multiple parts / subassemblies in the same file or a different file. This is going to retain the internal relations while we copy and paste our subassemblies and parts. This is also going to allow the use of internal, external, and learned relationships so that newly placed parts will get assembled with minimum clicks. It is as easy as Control-C and Control-V, and then just resolving those relationships. We are going to take a look at that in just a second. So I have an assembly here, and the first thing I'm going to do is change the configuration just so it's a little easier to see where I'm going to paste those parts at. Then I'm going to go to my second assembly, and I'm going to select the part files and the subassembly files that I want to be pasted into my previous assembly. I can either Control C or come up to the clipboard group up here and hit copy, but I am going to Control C, go back to my original assembly, Control V to place that, and what I'm going to get is the Assemble Multiple Components window that's going to pop up. And what this is going to do is it's going to show those unresolved relationships between those part files. So we see we have a mate and an axial line that's unresolved for that bolt. We'll come back to that, but we are going to go to the external relationships and solidify those first. So the first subassembly has been highlighted, and all I'm going to do is I'm going to just select the face to mate so that I can solve that relationship. Then I'm going to select the axis for that axial line and then another axis, and that's going to put that in place. It will automatically go to the next part file, and again I'm just going to create a mate command and then a planar line using my quick pick and then another planar line using the top face, and it's that easy. So a really powerful tool here, I am going to go to that first bolt, and you can see the relationships at the bottom are resolved because we created those relationships for that initial part file. So the next assembly update we're going to take a look at is the create internal components. So the internal component workflow is new, and the data resides within the assembly and the internal component collector in the Pathfinder. So we can see on the right hand side here we have our internal components collector and our Pathfinder with internal references. This is a little easier to understand just with a demonstration, so we're just going to get right into that. So for this example, I am going to open up a .x_t file, but for this example, I am going to change a couple options. So I'm going to go to my Options tab before I close. I am going to make sure that the Create Internal Components is switched on, so that when I open this file, it will create those internal components for me. So we're going to see in the Pathfinder, I do have several links and 2 bases. And I am going to look at the relationships that were associated here, and I see that they're all ground, and I'm going to delete out the 3 for the links because we don't want those grounded. We want to be able to move those. And then I am going to go up to my relationship assistant, and I am going to make sure that it's going to look at itself. And then I'm going to just select the whole body and say OK. And I am going to make sure mate and axial line are turned on, and I'm going to process that relationship assistant, accept those, and then finish that off. And now I can easily drag my linked components, and we can see those internal components again on the left-hand side in the Pathfinder. And again, a really easy and powerful tool. So the next thing we're going to look at are the part modeling updates and the very exciting subdivision modeling. So we're going to get into exactly what it is. We're going to look at what it means for the environment. So what is it? So it's a modeling technique that generates a stylized body using a polygonal cage to control its shape. So the body is generated through a set of rules that is repeatedly applied to each polygonal face, edge, vertex to generate the next level polygons, vertices, and their connectivity. So this is also known as cage modeling. So the control cage contains vertices, edges, and faces which control the body. So next thing we're going to look at is the environment. So it has its own environment and UI. It's available in both synchronous and ordered modeling. We're going to kind of see the difference in the in synchronous or ordered environments. So subdivision bodies are created using spline surface patches, so they can be placed in drawings with some limitations. and the resulting bodies are available for downstream applications that support spline faces and bodies. And then we're going to talk about the subdivision modeling cage primitives. So cage creation is done using primitives. We plan to allow protruding, revolve, and other methods later. The default creation method for all primitives is to place them at the origin with smooth edge options turned on. So we're going to go ahead and take a look at a couple examples of subdivision modeling. So for this command, we're going to look at our subdivision feature 1, and we're going to take a look at the fill command. So we're going to right click and go to that edit definition. And we are going to go to our fill command. And what we're going to do is I'm going to select the edges that I want to fill. We can see that gap in there. And as soon as I have 3 edges, it's going to start to fill that in. Okay. So we can see here that I've selected all of the edges of that surface that I want to fill in, and it kind of has this weird texture to it. And the problem with that is with this fill, it might not give us all of the capabilities that we want. So here in an example of moving this face, it might not look exactly right, and then I'm going to select the vertex, and it might not look correct up here while I move this up and down. So we can see there that there was a slight gap. So we are going to undo this, and we're going to try that fill command again. And this time we're just going to go square by square and accept that fill. So we can see there's my first fill, and I accepted that. There's my second, and then I'm going to fill in that last one. And now it kind of, you can see how it matches the pattern a little better. So each has its own cage, and we can manipulate that individually based on that fill, which is exactly what we're looking for. Okay. So for the next example, for the subdivision modeling, I am going to turn on my 3D sketch. And here we're in synchronous, so we have a handle associated with that subdivision feature. And we can see in the sketch that it wants me to move that handle over a little bit, so I am going to select all of these faces on this handle so that I can slide these all over. And you can see that I'm just selecting all of these faces again, and it's kind of got almost like a synchronous feel to it. I know we are in synchronous, but even in the ordered environment, we saw how easy it was to select those faces, edges, or vertices to move them. So I am going to move these over, and then I can just come in here and specifically readjust some of these individual faces. And again, this application is very easy to use. I feel like it's a lot easier if you are also used to the synchronous environment as well as the ordered, because it just kind of makes sense, right, on how the features move. We can see that I'm going to grab some of these vertices and move those specifically, and we're going to see that shape change. I can zoom in here and we can see that that's kind of a line there, and then I am going to come to the top here and just adjust this really quick just so you guys can kind of see. You can see that I grab that face and extend that up. Right. I can also grab the vertices and move that around. And again, I can grab that edge. So this is just a really powerful, really interesting tool. And the application for this is endless. So I am going to select these edges and pull these back just so I can kind of get a better shape in here, so I can move these into that sketch as well. We're going to see those nodes kind of even out when I place this back. And just like that, I'm done. So I'm going to shut that sketch off. I'm going to turn that off. I'm also going to clear out of that, and we're done with modifying our model. So the next thing we're going to look at in the part modeling updates for Solid Edge 2021 is the deviation analysis. So what this is, it's a method of inspection based on point-by-point comparisons of two objects. So in Solid Edge, comparisons can be made between the BREP and mesh models or the two mesh models. Reference and test bodies can be switched, and mesh bodies can be bodies imported from STL or JT. So we're going to take a closer look at this also. So for this deviation analysis example, the first thing we're going to do is we're going to look at the fact that we have two design bodies in here. We have a mesh body and then a solid body. So we're going to go to the reverse engineering tab, down to the deviation analysis, open this up. And the first thing it's going to do is pull up the deviation analysis settings. So here I can change the distance for the maximum deviation checking. I can change the decimal places. I can change the style and locations of our color bar settings. For this, I'm going to change this to 2 millimeters and 2 decimal places. Then I'm going to close this out. And the first body that I'm going to select just for this example is I'm going to select the solid body. And then I'm going to click the green check mark or right click and say OK. And then I am going to select the design mesh body. I do have the option here of selecting the body, a face, or a feature. But again, I'm going to stick to that body. And then I am going to make sure my settings are good. And then I'm going to say OK. And this is going to process. And here are my final results. So we can see on the right hand side, I have the deviation over here. I have the option of showing the max and min markers. I also have the option of showing the result information dialog box that I'm going to pull over here. And we can see that here. I am also going to pull down the Pathfinder, and we can see that it's also going to have more information on that left-hand upper corner for me there. And I am going to go into the settings and change this from 2 to 5 and just let that update real quick, and we're going to see how the results are going to change. Okay. And I am going to kind of just change the colors around and show you how to change from the left to the right. It's very easy. And then I'm going to go ahead and close this out. And this is just a really good example of that deviation analysis button, that example, that new feature inside the reverse engineering tab. So the next part modeling update we're going to take a look at is the fact that we can now easily change between the part environments by simply clicking on the proper Pathfinder bar. So here in this example, we can see that we first started off in synchronous, and then all we did was click on the ordered bar, and then the flat pattern bar, and then the simplified bar. And we can see the whole process here. It's a very simple change, but it makes all the difference in timing, which is great. The next update we have in the part modeling is the 3D curves in the 3D sketching tab now. So 3D curve is now available in 3D sketching environment. It's supported in the part, sheet metal, and assembly environment. It has basically the same functionality as the key point curve, which is great. Another update is that we can now have the property text linking to the text profile. So this is going to allow us to use the property text and the text profile in synchronous and ordered. So this is supported in the draft, part, sheet metal, and assembly environments. And this allows the user to update the text profile if the property text gets modified. So we're going to go ahead and take a look at an example of that. So for this example here, I am going to create a sketch on that right face, and I'm going to use the text property tool. And what I want you to know is that property text, that's the new function we're going to look at. I am going to quickly change the font to Arial, and I also can look at the properties down here. We can modify those if we want to, but I am going to go into that property text. And for this example, we have all kinds of options, right? We have all kinds of properties to choose from. But for this specific example, I am going to select the document number, and then I'm going to place a hyphen, and then I'm also going to select the revision number. And what that's going to do is it's going to bring in that demo 16-A that I can put on that face. And again, when those properties are updated, the text will automatically be updated because it is tied to those properties now. So it's a very cool tool that has been implemented inside Solid Edge 2021. So the next part modeling update is the conic curve in 2D Sketch. So now the user can create conic curves such as a parabola or a hyperbola or an ellipse using the row value in 2D sketching. So this supports constraints, relationships, and dimensions. And users are able to edit the curve using the control points and the vertex of the curve or by entering the row value. So we're going to take a look at what that new tool is, and it's very exciting. So for this example, I am in the ordered environment and I'm creating a new sketch. And under the curve, we can now see the conic curve. There are a lot of options here. We have a conic, hyperbola, a parabola, and an ellipse. And we're going to go through all of these individually. We also have the opportunity to enter in a new row value here. So if I select conic, I'm going to select the first point, and then the second point, and that's the length of my curve. And then I'm going to select the control point, right? So that control point is going to select the location of that node. And then I'm going to enter in a row value. And we can see here that I have now a conic curve that I can control with these specific points. Okay, and I can also come in here, enter in a new row value if I want. I cannot change what kind of curve it is though. Okay, so once it's placed, you can't change the curve. I am going to go to our hyperbola now, and again, I'm just going to select my 2 points for the length, select that control point, and then adjust the row value using my mouse. Here we do have a hyperbola. And again, we can edit that and move that around using the control points. Okay. So the next example I'm going to show you is a parabola. So parabolas are a little different. The row value is set to 0.5. We can see that here. And I can come in here and click on this value, click on that control value, just like the others. But for parabolas, it's kind of special. The row value isn't going to change. Okay. And the last one is an ellipse. And again, pick those 2 points, pick my control point, use my mouse to adjust the row value. Okay, for the ellipse, it is going to stay there as well in that value. And another thing that I want to point out is if you're ever wondering what values you should use for the type of curves, they are in the, when you hover over it, it will tell you the row values that are associated with those kinds of curves, which is a really cool tool. So here we can see that I've created this sketch using our conic curves. We can see the row value here, as well as the other row value for my other line. And we can make what looks like a radial dish using these new conic curves and our revolve tool. And again, so just a really cool new feature added to Solid Edge 2021. So for the drafting updates, I only have one slide for this. Some more drafting updates will either be in part 2 or part 3, and they just have more to do with the other features, some of the new features inside Solid Edge 2021. So be on the lookout for those. but we do have new symbols for surface finish, feature specifications, and tolerances. So 22 new symbols from iOS 11.01 and iOS 14.405, and it's also supported in model-based definition and drafting. And now we are going to get into that solid edge data management updates. We do have a new function that is called shape search. So we're going to search for 3D models based on the shape of a new or existing model. This is going to search the active or selected model from Solid Edge with a single click, and then you can filter the results in your browser using properties. This is included with Solid Edge, and then you can also open a result and compare those models inside Solid Edge. So a really powerful, really cool tool. We also have the Open As command. So the new Open As command launches the Open File dialog where users can assign open attributes. The command is available in Windows Search Dialogs, MRU, and Solid Edge Advanced Search. Open As redirects the users to the file locations, and files are then opened in Solid Edge. So again, this is just something to be on the lookout for. And then last but not least, we're going to take a look at the Pack and Go enhancements inside the Solid Edge data management updates. So the drawings outside the assembly folder structure will also be included during a Pack and Go now. When Solid Edge data management is off, users can define a scope to index. Drawings linked to the components will be fetched. And when Solid Edge data management is on, indexed locations included the location where the drawings reside. So again, just a really cool function to look out for inside the data management updates. And that is all I have for you today. If you have any questions, you can ask at the very end, or you can send me a personal email at grace.farrow@prolim.com. Again, my name is Grace Farrow, Solid Edge Application Engineer here for Prolim, and thank you very much for coming today.